Very good morning to all. Uh, now, I, now I request our HOD, Dr. Sridhar sir, Department of Computer Science and Engineering, to welcome all the participants and our today's chief guest. Please, sir.
Okay, ma'am. So, good morning to all. It's my pleasure to welcome you all to the AICT sponsored 6 days online STTP on recent trends in machine learning and big data analytics using Python programming from 4th January 2021 to 9th January 2021. So first, in this occasion, I thank management and Dr. Paman Raja, principal, then Dr. Naluswamy, Director Administration, then Dr. D. Devakumar, Director IRRP, for providing continuous encouragement and support for conducting 2 series of STTP. So now this pandemic situation, to meet the dynamic technological changes, so efficient training programs are needed for faculty members. So I hope this STTP will meet out the expectation of participants. First, I welcome the Dr. Prabha Selvaraj, VIT Andhra Pradesh. She will deliver today's session on behalf of Department of Computer Science and Engineering. So I welcome you, ma'am. Next, I welcome to Dr. Geeta, Program Coordinator, and the faculty members of Excel Group institutions and faculty members of Department of Computer Science and Engineering. The next, I welcome the participants from various institutions who are all set to make this STTP as grand success. Thank you, Honorable President.
Thank you, sir. Now it's my pleasure to welcome our today's resource person and chief guest, Dr. Prabha Selvaraj. She is working as an assistant professor, senior grade, VIT Andhra Pradesh. She has completed her UG, PG, and PhD in Anna University, Chennai, and she has 20 years of experience in teaching and industry. Her research interests include data mining, security, wireless sensor network, IoT, information retrieval system, image processing, machine learning, and blockchain. She has published 30 papers in various national and international journals and conferences, and also chapters in the area of big data analytics, IoT, blockchain, and image processing. She has published 3 patents. She has received a top Best Faculty Award in CSE by EET CRS and Best Educators Award in 2018 by IARDO and Distinguished Leader in Engineering Discipline 2019 by Higher Education Leadership Awards. She is a reviewer in few national and international journals and conferences. So on behalf of Department of Computer Science and Engineering, Excel Engineering College, I would like to welcome today's chief guest and resource person, Dr. Prabha Selvaraj, ma'am. Welcome you, ma'am.
Thank you, ma'am.
Now the session is handed over to our today's chief guest, resource person, Prabha Selvaraj, ma'am. Please, ma'am.
Yeah, ma'am. Good morning, all. Yeah, Happy New Year to all. And it's my pleasure to be a part of this STTP. And I thank Geeta for inviting me as a resource person. Okay. So, shall I start, ma'am? So,
Yes,
shall I
ma'am.
share my presentation?
Yes, ma'am.
Okay. Is it visible, ma'am?
Visible, ma'am.
Is it okay?
Okay, ma'am.
Okay, fine.
Screen இன்னும் கொஞ்சம் பெருசா இருக்கணுமா? Text தெரியலையோ?
If it is so, then we'll move. Is it okay, ma'am? Yeah.
Ma'am, okay, ma'am. Visible, ma'am.
Yeah, I'm audible now. Okay.
Okay, ma'am.
So, very good morning to one and all. Today's topic is machine learning and its application and machine learning algorithm. So, before getting into machine learning, I just want to give a few input regarding statistics because statistics and the machine learning join hands together and work. Before getting into algorithm, so you should be familiar with the few terms in statistics and a few concepts clearly so that you'll be able to work on machine learning algorithms. So as we all know, first data, so it is the lowest level of abstraction. So from which you will get the knowledge. So whatever knowledge you want to get, you will be getting it. So as we see the example here, so some table, so a set of very rows is given and it will be considered as a data table, raw data table. So it's nothing but a collection of information that you just got received from somewhere. You want over which you want to do some process. So here, so we simply collect the data and put it in the database, and you call that as raw data table. So now, first thing in whatever process you are doing, first you have to explore the data. That is the most important step you have to perform. So one of the first thing you have to do is you whatever data you are collected. So that is your new data for you because you want to get some inference out of that data. That is, you want to predict some information from it. So first thing is you have to explore the data. You have to know about the data completely. So by asking few questions. So what the questions are, what variables are included? So what information are we getting? So when you see the data, you have to analyze what is the variable and what information are we getting. Next thing you have to concentrate is format of the variable, the type. So whether it is a string or numerical, etc. So then comes your type of variable. So you say it is in string or numeric, whatever it be. Next, you have to categorize the type of variable. So whether it is continuous, whether it is discrete or categorical. And you have to check one more thing whether it is a sample data or a population. So I hope you all know what is sample data and population in the sense the entire data. For example, if I want to consider the average weight of the Indian, then Indian citizen, then I have to consider the entire population so that you can call it as a population. Suppose if I take only the place Namakkal district alone, then it will be considered as a sample. So all these things you have to explore first. So after looking at the data you want to know, for example, if I want to analyze the given
Ma'am,
data
excuse me,
which
ma'am.
is
Sorry
yeah,
for the
ma'am.
ma'am. Sound audible இல்லைங்க ma'am கொஞ்சம்.
Is it okay now, ma'am?
Now okay ma'am.
Now okay, okay, fine.
Thank you ma'am.
Yeah. So after looking at the data given in the table, so here what they have done is they have calculated some SAT score and based on that they are giving the score. So what, how many females are there? How many males are there? What is the average age? And whether they have done an undergraduate or a graduate student, what is the average score? So like this, you have to ask many questions on the data base you have collected, the new data set. So once you explore the data, then it is very easy for the analysis. So the next main thing is type of data or variable. As I told you, when I say the format, then you have to remember it as a string or a numeric, whatever it be. When it comes to type of data or variables, you are classifying it as discrete and continuous. So among that you have categorical data, which is a non-numeric data. So categorical in the sense I can ask what is the favorite color, what is the birthplace, what a type of car, like that. So when I say quantitative data, then you have to quantity. So you have to remember it is a numerical value. So among quantitative data, you have two types of quantitative data. One is discrete data, and another one is continuous data. So when I say discrete data, you'll have a specific value, 1 2 5, something like. When I say continuous data, you can take any numerical value like height 63.5, something like that. So it is continuous data. So these are the two quantitative data type. And next is the variable. When I say variable, it is a value which you may change within the scope of a given problem, and you can apply perform some operation. And next one is discrete and continuous. When I say discrete value, it has a specific value, and when I say it as a continuous, then you have to take a range of value, so it will be varying. So here the discrete value variable is again classified into two. One is nominal and another one is ordinal. When I say nominal, so there is no order at all. So you can say it is a color, nationality, something like that. When you say ordinal value, it is ordered. So worst, average, and best, something like that. So it is ordered. So next one, so let us take few examples and categorize data type. When I say gender, it comes into nominal. When I say ranking, it comes into ordinal. And when I say temperature, so it is the interval. And when I say weight ratio, so these are all the few data types generally we use in our process. And so when I say category, see, it deals with description. So colors, texture, smell, taste, appearance, something like that. So when you are saying it deals with number, it is measured. So it is quantitative. So these things you should remember. And next one is data statistics. So before that, you have to know about statistics. So statistics is nothing but a set of mathematical methods and a tool which will answer all your important questions about the data. So here what we are trying to do is we are going to try to convert the data to knowledge. So you are given a raw data, and out of which you are going to extract the knowledge which you want. So there are two types of statistics is available. One is descriptive statistics, so and the other one is inferential statistics. So why we are going for statistics, it will help you to answer all these kind of questions. What features are most important? So I was given a raw data table, but I don't know which column is more important, which feature is more important. So when you apply statistics, then you can get information about all those things. What features are more important? How should we design the experiment? So if I want to develop a product, I have to first design. So how it should be designed, and what is the performance measure I have to consider, and what is the most common and expected output. So the output, which is more important, and you have to differentiate. When I say data, I should be able to classify whether it is a noise or a valid data. So these type of questions is answerable by your statistics. That is why we use statistics for analyzing. So when I say types of statistics, as I told you, it is descriptive statistics and inferential statistics. This descriptive statistics will offer methods to summarize the data. So, whenever you want to summarize any data, transforming raw observation, you want to convert it into an meaningful information and interpret something, then you have to go with descriptive statistics. When I say inferential statistic, so this will apply few methods to study the experiment first over a small sample, and then from that you have to derive the information inference for the entire population. So that is the difference between descriptive and inferential statistics. So Descriptive statistics, it will describe the data that is being analyzed, but it will not allow you to draw any conclusion. So, if at all you want to draw any conclusion, then you have to go with your inferential statistics. So, where you will take a sample of data, perform the process, and you will come out with the inference for the entire population. So, these and your descriptive status. When I want to consider descriptive statistics, the measure of central tendency and dispersion. You will be calculating all these things. I'll tell you later what is central tendency and all. And summary graph. So I want to summarize. I want to analyze the sales of the entire month. Then I'll go with summarization. And if at all I want to estimate something, then I'll go with inferential statistics where I'll use estimation and hypothesis testing. So, whenever I say descriptive statistics, it is used as a tool for summarizing, organizing, and simplifying data. So, what are all descriptive statistics? So, you can represent it using a graph, tables, then measure of tendency, and then measure of variables. When I say inferential statistics, it is a tool for tools for generalizing beyond actual observation, because you will be analyzing a sample of data, and from that you are going to extract some information out of it. So the statistics and machine learning are two closely related area of study. So whenever you want to go with the machine learning, first you have to study the statistic, because it is a prerequisite for machine learning, which will help you to select the data, evaluate the data, and interpret predictive models. So from this we can understand that statistic, it is a science of collecting, organizing, presenting, analyzing, and interpreting the numerical data in order to make decision. So these are the things about your statistics. So coming to descriptive, as I told you, study the basic feature of the data, which is going to describe what is the data and what the data shows. So if you're going to analyze what is the data and what the data is going to show, then you have to go with descriptive statistics. And the statistic method used for this is summarization and collection of data. So here, descriptive statistics, it is going to analyze the way, data. It is going to represent it as a picture, graph, and figures. So mostly this descriptive data will be used for organizing, summarizing, and presenting data in an informative way. For example, so I have a report, consumer report. I have an electric washing machine owners. So out of that, nine problems per 100 machines. Out of the nine customer, 100 customers, 9% reported during some 2019. So the statistics says that 9 describes number of problems. Out of 100 machine, 9 machines are problem. So if you want to get information about something like this, then you have to apply descriptive statistics. Then coming to inferential statistics, the study patterns. So you will be analyzing the pattern, randomness, and uncertainty in the data. So whenever I say inferential statistics, it's nothing but a decision, or it is an estimation or prediction or generalization about the population based on the sample. So when I say population, you have to remember that it is collection of all possible values, objects, or measurements which you are in of interest. So a sample is nothing but a part of the population of interest. So, when I say I want to analyze a TV network which is continuously monitoring the popularity of the program, so in a particular Sun TV, something like that, I want to find out which program is having higher popularity. So now I have to take a sample of few viewers of that particular channel, and then I have to analyze which program is better. So I'm taking a sample from the population, and then I'm going to give the inference which is the most popular program on that channel. Next, the data type and statistical analysis. the type of data you collected in your study. It will determine the statistical analysis model which you are going to use. So, what kind of statistical analysis you want to apply? So, that is decided by the type of data you collect for your study. So, one of the primary purpose of classifying the variables according to their level or scale of measurement is to make a choice about your statistical analysis which you want to use for analyzing the data. So if there are certain statistical analysis which are only meaningful for data which are measured at say certain measurement scales. So next, when you consider a machine learning project, so you have to perform all these steps. First you have to take the problem statement, then you have to initially explore the data, then you have to clean the data, and you have to prepare the data and set for the transformation, and then you have to select the model and evaluate, and you have to tune the model. What I mean by defining a problem statement, so this is the crucial part of your predictive modeling because you will be giving the actual definition of the problem. So real objective you want to pursue, so that is your problem statement. It will help you to decide the type of problem which you are going to dealing with, whether it is a classification problem or a regression problem. So you have to analyze the problem statement, so you have to define the problem statement correctly. So and it will help us to decide the structure and what type of input you want to give, and what type of output you are expecting, and what are the measures regarding this objective. So, problem framing is not always straightforward. It is not a simple task because you are new to machine learning. So, it has to you have to perform significant exploration of the observation in the specific domain in which you are going to define the problem statement. So, you have to perform exploratory data analysis and data mining before defining the problem statement. So then only you will be able to define the problem. You have to specify the correct type of input, what is the output you expect, and what are the metrics. So EDA and data mining is the process here. Next, initial data exploration. So here you have to understand the data deeply by understanding the distribution of variables and what is the relationship between the variables in your data. Is there any dependent and independent variable among the data you have? So you have to deeply understand the distribution and the relation between the variables. So in case when it will help you to gain the information about all these things. So if you are an expert or a newcomer, you have to do the exploration. So to understand the system. Next, data cleaning. So often the data cleaning point you have collected from your experiment or a data repository, which is the most important thing. So the data may have been.
Ma'am, ma'am, ma'am,
Yeah,
ma'am, ma'am, slide மூவ் ஆகுறது எங்களுக்கு மூவ் ஆகல.
I'm having the same slide, madam. Machine learning project consists of following
Okay,
tasks.
okay, okay. Okay, participants also have
Okay,
asked
and
questions. So okay, ma'am.
okay, I didn't move it. I'm just explaining it. That's all.
Okay,
It's a
okay,
simple. Uh,
okay, ma'am.
so when I say data cleaning, the data may have been subjected to processes or manipulations that damaged its integrity. So it might have been damaged. So some common examples of data cleaning is missing value, data corruption, data error, or unformatted data. All these things. So first you have to clean the data, so you have to identify the outlier and the missing value imputation. So these are the few methods that you will adapt for data cleaning. Next is your data preparation and setting up transformation pipelines. So if suppose if your data contains error and inconsistency, you cannot use it directly for modeling. So because you have to prepare the data first and transfer it. So first is the data might need to go through a set of transformation to change its shape. According to your requirement, you have to structure and you have to make it in such a way that it is suitable for your problem which you have defined. So then you can develop a pipeline of such transformation to apply the data to produce the consistent and compatible input for the model. So what are the different things you will apply? Data sampling, future selection, data transforms, scaling, encoding, or these are the some few techniques for these data preparation. Next is your model selection and evaluation, so which is the key step in solving a predictive problem, because selecting and evaluating the learning method. So whatever you so far you have explored, you're going to select and evaluate the method. So estimation statistics, you have to use estimation statistics which will help you to score the model prediction on unseen data, because I'll train the data with whatever data set I have, but in future I should be able to predict if I give some other input also. So for that estimation statistic will be helpful. So experimental design, when you say, it is a subpart of statistics which will derive you the selection and evaluation process of a model. So you need a good understanding of statistical hypothesis test and estimation statistics. So if you want to have perform good model selection evaluation. And the last step is fine tuning the model. So almost every machine learning algorithm has a set of hyperparameter that will allow you to customize the learning method which you have chosen for problem framing. So often we will not directly take it. So you will often use empirical method. So that means you will be you're going with based on observation or experience rather than applying it theoretically. So you will always verify it by the observed data and the past experience. So instead of going theoretically or analytical. Okay. So this requires a large suite of experiments in order to evaluate the effect of different parameter setting on the performance of the model. So based on that, you will fine tune. And next, important statistics concept. So before getting into deep into statistics, so you have to know getting started. So what is it getting started? That's nothing but understanding the type of data, estimation of location, estimation of variability in the data, distribution, whether it is binary, categorical, correlated, relationship between different types of variable. So all these things you have to analyze. Next comes your distribution of statistics, whether it is a random number or large number, central limit theorem, standard error. These are the few that you will use it for distribution of statistics. Next, data sampling and distribution. You can go with random sample. So you can randomly pick, for example, if I want to take, find out the average weight of an Indian, so I need not go with numerical district. Randomly, I can pick a few data from each state and I can analyze it. So sample bias, selection bias sampling, distribution bootstrapping, confidence interval, all these are comes under your data sampling and distribution. So statistical experiments and significant testing, so you will be conducting hypothesis testing, and then you will be analyzing the significance of your system. And the last one is non-parametric statistic method. So you will rank the data, you will normalize the data, and then you will find out the rank correlation, rank significant test, independent test, all those things. So these are all said to be non-parametric statistic method. So as I told you, population. So if you consider the entire data set, then you will call that as a population. And if you consider a subpart of population, then you call it as a sample data. So you will be representing like this. Next, the most important thing, generalization in machine learning. In machine learning, we describe the learning of the target function from training the data. So, training the data as inductive learning. What do you mean by inductive learning? So, induction refers to learning general concept. From a specific example, you will be learning the general concept. See, I'm just taking a sample from one district, and I'm trying to judge it for the entire Indian citizen. Wait, so induction refers to a learning general concept from specific example, which is exactly the problem that supervised machine learning problem aims to solve. So this is from different from deduction. So because it will seek to learn a specific concept from general rules. So when you we say induction, from a specific example, you will derive general concept. So, generalization refers to how well the concept learned by machine learning model. So, when you apply to specific example not seen by the model when it was learning, because I will apply a sample, but when I apply a specific example over the model, I'll be able to learn that also. So that is said to be generalization. So, how well the concept is learned by the machine learning model when you apply a specific example which is not seen by the model when it was learning. So, when it was training, it is not available. Now, how it is predicting? So, that is generalization. So, the goal of a good machine learning model is to generalize well. You have to generalize well because it should be able to predict everything correctly. So, to some extent, so if it is not 100%, at least to 90 to 95%, it should give correct answer. So you have to generalize well from the training data to any data from the problem definition. So that is what said to be generalization. This will allow us to make
Ma'am,
prediction in future. Yeah,
the slides are not moving, ma'am. We are seeing able to see only the second slide, ma'am.
you are able to see generalization in machine learning,
No,
madam.
ma'am. We am seeing only the second slide, data slide, ma'am.
Oh my God. So shall
Yeah.
I close
Yes,
it
ma'am.
and
Now I'm
open it
able.
again?
Yeah, ma'am. Now I'm able to see generalization machine learning.
Okay.
Thank you, ma'am. Thank
What
you.
happens? I don't know.
Thank you, ma'am.
You're able to see, madam?
Yes, ma'am. I'm able to see now, ma'am.
Okay, one second. So, which is the screen I'm seeing?
Generalization in machine learning. What are overfitting and underfitting in machine learning?
Okay, I think it got stuck. I'm trying to move, but
Ma'am, that's on previously I saw display, ma'am.
one second, madam. I'll just select it now.
Yeah.
Now you're able to see. Is this okay, ma'am?
Generalization slide is viewed, ma'am.
Okay, fine. So, generalization is refers to how well the concept learned by the machine learning when you apply to a specific example which is not given already while it was learning training period, it is not given, but when you give a new example you should be able to identify it correctly. So if you are able to do this generalization well, then it is said to be a good machine learning model. So this allows you to make prediction in the future which is never seen. The data which is never seen is given as an input, but even then it is able to predict it correctly. So you have to, when you want to design a good machine learning model, then you have to generalize it well. So there is a terminology used in machine learning when we talk about how well a machine learning model learns and generalizes. If you want to answer this question, then you have to understand overfitting and underfitting. So this two things, this two concept will be giving you whether it is generalized well or not. So what are overfitting and underfitting in machine learning? So when you say machine learning model, first thing you have to remember is you have to generalize it well. So generalization is nothing but when you give any type of data which is not seen also, it should be able to give the correct output. So that is second. When you, so among this overfitting and underfitting, so when you overfit also it is a problem, when you underfit also it is a problem. So if you want to learn about overfitting and underfitting, you have to understand one more thing also, bias and various trade-off. So these three concepts are main thing which will identify whether your machine learning model is good model or not. So building on that idea, your overfitting and underfitting refers to the deficiency of the model performance. So if you find overfitting or underfitting, then your performance of the model will be poor. So this means you have to generalize it well, so in such a way that it neither underfit nor overfit. So before getting into the overfitting and underfitting, so you have to know few terms. Signal. When I say whenever a signal is used, it is nothing but the underlying pattern of the data. So that will help the model to learn from the data. That you call it as a signal. And noise, unnecessary and irrelevant data, which will degrade the performance of the model. You call it as a that call that data as a noise. And when I say bias, it is a prediction error. So because of this, there is a difference between your what value you actually expected and the predicted value. So if there is a difference, then you call that as bias. So you call that bias as a prediction error. So it is deviating from the actual value expected. And when I say variance, so perform well with the training data set. But whenever apply the test data, many times we'll get this problem. So when we train the data, it will give 90%. When we apply the testing data, the variance will come. So it will increase. There will be a problem in the accuracy. So these are the few things that you have to remember. So let us say that we are trying to build a machine learning model for the data set. So whatever data you have, you will put it in that graph, and you will apply some regression model or line fitting process to find out whether it is overfitting or underfitting. So first thing is training the stage. So training the linear regression. Suppose consider that I'm going to take one machine learning model, linear regression model. So what you have to do is, I have to find out a line in such a way that all the data points is close to that line. So if you are able to fit a line like that, then it is a regression line, good regression line. So this goes through multiple iteration. You cannot do it directly. So in next when we see linear regression, I'll take an example and I'll show you how it gets deviated and what technique you apply to find out the best regression line. So so now I'll talk generally, so that we'll understand overfitting and underfitting. So I just want to draw a line in such a way that all the data points are close to that line. So if I'm able to do that, then it is a good line. Now, overfitting in machine learning, what it means, data is trained too well. So too much data, so too much of anything is also good for nothing only, because if you train data too much, then again it results in overfitting. What happens when overfitting happens? When it will happen? When a model learns the detail and noise in the training data to the extent the negatively impacts the it will you have a negative impact on the performance of the model. So you are training it too much, so what happens now, it has a negative impact on the performance of the model. This means the noise or random fluctuation in the training data is picked up and learned as concept by the model. So it is taking all the noise and the random fluctuation, and it is generating a model. So these concepts do not apply to the new data because it always finds or goes with the noise and random fluctuation. And when I give some new data, it will have a result, it will not be more accurate. So overfitting is again a problem. You see, the same example, when I draw a line like this, then I am just finding out the points. I am drawing a line in such a way that all the points are close to the line. So from this, I can just identify only one point which is away as an outlier. But you see here, I am connecting all the points. I'm learning the model too much. So what happens? It understands all the even outlier noise, random flag, everything is understand, and it learns as a concept by the model. So it looks good, thinking we may think that it connects all the point, but really it is not good, because when you overfit, then it will result, it will degrade the performance of the model. So you have to see in such a way that overfitting is not done. So you have to do a correct generalization. Okay. So overfitting, so what you have to do, we always want to find the trend, not fit the line to all the data points. You have to remember one thing, we should not keep in mind that we should connect all the points. That is not necessary, because overfitting or high variance will lead to bad model. So, what is the use if a model that has learned very well from the training data, but still it is not able to predict a correct information for the new input? So, if you overfit the model, then again it is going to be useless. So, you have to find, and you should keep in mind that you should not always try to connect all the data points. Overfitting will give you a bad model. So when you apply the algorithm, the error of the model on the training data goes down. So does the error on the tested data also. That is why we always clean the data and we will train it. If we train for too long, the performance on the training data set, it will continue to decrease the performance. So the model becomes overfitting. So the learning the irrelevant detail and noise in the training data should be avoided. So that is why when we apply, before applying it, we used to clean the data and then apply. At the same time, the error for the test starts to rise again as a model ability to generalize decreases. Again, it will decreases. So you have to find the model in such a way that so it is not overfitting mind. So how to limit your overfitting? So overfitting, you can resample, you can go with resample, or you can have a separate validation data set, training set, and testing set. You can have it separately. So most popular technique is resampling technique, where you will use k-fold cross validation, which will allow you to train and test your model k times on different data set. You will train and you will test on the data set. So that is called as k fold. So you will have k times you will be training and testing. So that will give you a that will not create an overfitting problem. So validation data set is nothing but a subset of your training data set. So you will not apply the entire data set for training. So you will hold back some subset of training data set, and you will later on use it. So after you have selected and tuned your machine learning algorithm on your training data, you can evaluate your model by using this validation data set. You call it as a testing data set. Okay. So, but if you want to limit the overfitting, we'll go with cross validation or weak sampling method. So next, this is all about overfitting in machine learning. Next, underfitting in machine learning. What do you mean by underfitting? So the model that can neither model the training data or generalize for new data. So it is not able to find a perfect model for the training data, as well as if you give a new data also, it is not able to. That means what is the problem? We want to model to learn from the training data, but we don't want it to learn too much. So because we don't want to have overfitting problem, so what we will do is we'll stop the early training process and we will train the model. So it will not have enough pattern for training data. Thinking that if we give too much training data, we thinking that it will overfit. If you reduce it, then what will happen? You'll not be able to learn enough pattern from the training data. So and possibly it will not be able to capture the correct thing, and it will result in under fitting. So this is the example. I have a line like this. So it will not cover anything because it is not able to learn the patterns correctly. So it is able to connect only 4, 5, 6, 7 points are close, others are far. So underfitting is a case where the model has not learned enough from the training data. So which will result in low generalization and unreliable prediction will be done. So but when you say good machine learning technique, the model, then it should have a good generalization. So, as you probably expected, underfitting is just as bad for the generalization model as overfitting also. But mostly, overfitting will be the problem. We will not go with underfitting because we always train with good amount of data. So in high bias, the model might not have enough flexibility in terms of line fitting. So this line, that is said to be line fitting. So you will not have enough flexibility in line in terms of line fitting. So which will not you will not be able to generalize it well. So then if you're not able to generalize, then the model which you have developed is of not reliable. So underfitting is not discussed because we always used to have enough data for training. So next, bias variance trade-off. What is the right measure? So depending on the model, you have to find out. It should not lie between. It will not be overfitting, and it will not be. It should not be underfitting. So this is you have to find out. Yeah, good model in between these two. So machine learning model fulfill their purpose when they generalize well. So this you have to take care. How to avoid overfitting in the model? All these things methods can be cross validation, training with more data, removing the features, unwanted features you can remove, early stopping the training, regularization, ensembling. These are the few methods which will avoid overfitting the data. So measure of central tendency, this is more
Ma'am,
important.
excuse me,
Yeah.
ma'am.
Yes, madam.
Ma'am, slide move ஆகல.
Now you are able to see, ma'am,
மேம் ஸ்லைடு
measure of
வியூ ஆகுது. ஸ்லைடு வியூ ஆகுது மேம். பட் நெக்ஸ்ட் ஸ்லைடு மூவ் ஆகல.
now you are able to see, ma'am, measure of central tendency.
இல்ல மேம்.
No, I don't know what happens now.
Now it's okay ma'am. Measure of central tendency.
Okay, I think
நெக்ஸ்ட் ஸ்லைடு நீங்க மூவ் பண்றப்ப இந்த வியூ ஆகல மேம்.
okay. So when I don't have full screen view, na, you are able to view it. When I make it full screen, na, buffer ஆகுதுன்னு நினைக்கிறேன். So it is taking some time. Now you are able to see
Screen
measure
is
of
visible.
central.
Screen visible ma'am.
Okay, measure of central tendency
When
is there.
when you are skipping to the next slide, we couldn't able to get that current slide ma'am.
Okay, now you are able to see, ma'am, measure of central tendency.
Now it is okay ma'am.
Okay, ma'am.
Again நீங்க மூவ் பண்றப்ப எங்களுக்கு மூவ் ஆகல.
Now you are able to see the graph, madam.
No ma'am.
I think this is there. Now is
Now
it
it is
visible?
okay. Now it is visible
Now
ma'am.
you are able to see graph.
Graph, now graph is visible. Okay.
The problem is if I keep the full screen, if I scroll it, you are not able to see. Now it is okay, na?
Now it is okay ma'am.
Okay, okay, madam.
Okay ma'am.
I should not go with full screen mode. I have to keep it like this. Okay.
Okay.
So measure of central tendency. So it is a single value which will attempt to describe a set of data. So you have to find out the central position within the set of data. So I have to identify the middle value, central position within that set of data. So if I'm able to do that, that is said to be measure of central tendency. How to do it? Mostly I'll go with the measure of tendency. I'll go with mean, median, mode. All these things will be used as a measure of central tendency. It is also called as measure of central location or summary statistics, measure of central tendency. So now you see this example. There are three, four examples are there. In the first example, so I have a staff one, two, three. These are I have. I'm taking salary of 10 staff member. Madam, now you are able to see the graph, ma'am.
Yes, ma'am.
Okay. So now, if you consider the salary of a 10 staff member, you see the salary. First salary is 15, 18, 16. But when you consider the ninth and 10th salary, it is 90 and 95. Suppose if I want to find out the central tendency, measure of tendency using mean, what will happen? I will add everything and I will find out a value, but it will not be correct because you see my last ninth and 10th value is more. It is a skewed data. You call it as a skewed data because with the skewed data I'll not be able to apply mean. So when there is no skewness, then you can go with mean. So if the data is skewed, you cannot use mean for finding the measure of central tendency. Instead, you have to go with median. What is median? You will sort the data and find out the middle value. So you will sort the value salary and then you will find out the middle value. So in that case, maybe 15 will be the 15 or 16 will be the media central measure of central tendency. So middle position. And when you consider the first graph mode, it is very simple. So most frequently occurring value will be considered, so that is easy mode. You can consider use mode in that case. So these are the type of variable and best measure of central tendency. When you go with nominal data, then you have to go with mode. When you go with ordinal data, then you have to go with median. When you go with the interval or ratio, you should see to that it is not skewed. If it is skewed, then you have to go with median. If it is not skewed, then you can use mean. And in the second graph, you see there are two graph lines with bars which is having the same height. That means two values are more frequently occurring. In this case, I can go with the average of these two values. That is why it is called two mode. In the last graph, only one value has highest frequency, so I can go with more. So in order to find out the measure, you find the measure of central tendency based on the data value. You have to choose whether it is mean, median, or mode. So if you randomly choose it, then it is going to be a problem, because if in case it is a skewed data, then you will not be able to apply mean. That you should remember. So these are all few example. What is a typical student in the class doing? If you want to compare the performance of any single student and against a group, so what you will do among that group, whichever who is having the high performance, you will compare with that. Now, there is an example given here. I'm going to find out. So, transportation, best transformation. I'm having collected some transport mode data, auto, office, and own car. But you see, mean, median, and mode all are same. For everything, it is 99. With this kind of data, I'll not be able to identify anything. So these are not sufficient to find out. So next important thing is skewness. So what is skewness? Lack of symmetry. So whenever I take any system, I will always go with that bell shaped curve, which is normalized, evenly distributed. So, lack of symmetricity. So, here, if you see towards the right side, it is skewed. A distribution is skewed if one of its tail is longer than the other. So, both the tails, so left hand side and right side issue, if it is even, then it is okay. If it is longer in right side, then it is said to be positive skew, and if it is longer in the left side, then you call it as a negative skew. So in case of positive skew, your mean will be greater than median and mode. In case of negative skew, so if you calculate the value using statistics, when you find see the value of mean, median, mode itself, you can identify whether it is positive skew or negative skew. So if your mean is greater than median is greater than mode, then you can say it as positive skew. Your tail right side is longer, and if it is mean is less than median or less than mode, then you can say that it is negative skew. Your tail is left side longer. Okay. So normal distribution. So normal distribution is a pattern for the distribution of a set of data which follows bell curve. This is what I was saying. Bell curve. So the curve is concentrated in the center. So it is evenly distributed, symmetric. So always we will go with normal distribution. It has mean, median, and mode all coinciding at the peak. So area under the curve we say it as 1. So now in this you have to see this one 68, 95, 99.7 rule. So this is an empirical rule states that a normal distribution. What it says, see the red color. When you consider, if I consider the red color, I call it as one standard deviation, two standard deviation, and three standard deviation of the mean. So first, one standard deviation in the sense 68 percentage of the data will be available in the red region. When I say two standard of the mean, the data will fall in the two standard of the mean, then it will fall within this 95% green area. So where all the data will fall into 95 percentage of the data will fall in the green area. So within that green area. And the last one is 3 SD of the mean, where the up to this blue, all the data will fit into this blue area until the blue area. So this you call it as 68, 95, and 99.7 rule. Next important thing you should know is kurtosis. Kurtosis measures the peakness of a distribution. The curve peakness is measured using the kurtosis. Kurtosis is a statistical measure which will define how heavily the tail of the distribution is differing from the normal distribution. You are going to compare your normal distribution with this the peakness of your graph. So higher the kurtosis means more the variance. That means the result is infrequent, extremely deviating. In so kurtosis should be for the normal distribution is 3. So next one is correlation. So this is another important term, correlation. So what you are going to your correlation, you are going to find out the relationship between the variables. So with from one each variable, you are going to find out the correlation. So correlation coefficient will indicate the strengthness of the relation. So between any two variable. Suppose if I am saying when I have a function like this, x is equal to y is equal to f of x. As the value of x increases, y also increases. That means it is positive correlation because when this one increases, the other x variable increases, y also increases. On the other hand, when you increase the x, if the value of y decreases, then what will happen? It is perfect negative correlation because one variable is depending on the other variable. Since y equal to f of x, so if I increase the x value, y is decreasing. That means it is opposite direction. So you call this as negative correlation, perfect negative correlation. If there is no do not have any relationship, then there you say it as no correlation is available. Next, data analyzing is using graph. So suppose as I told you if you want to summarize or if you want to get information, we represent using a table, chart, and graph. Out of that, we will get some information. So consider that I have taken one example where in a cafeteria, so you have collected data on how much milk was sold in first week, say, one week. So first day, Monday, Tuesday, Wednesday, Thursday, and Friday. So the date, chocolate, strawberry, and white are the flavors, and based on this, you are going to perform the analysis. This is table representation. Instead of that, if at all I want to go with graphical representation of variable, I have different graphs, but you should know when to use which graph: bar graph, pie graph, and line graph. So when I say bar graph, if at all I want to show the relationship between groups, so then I will go with bar graph. Suppose you see the first diagram, I am just taking only chocolate milk sold alone. So only I am taking one group chocolate milk, and I am finding out what is the sales of that chocolate milk on every day: Monday, Tuesday, Wednesday, Thursday, and Friday. Then, if you want to represent like this, on what day did they sell the most chocolate milk? So, Wednesday it is high. That means from this I can identify Wednesday chocolate milk is sold high. So, if you want to do some comparison like this, so then you have to go with bar chart. Next is pie chart. So now, a circle graph is used to show how a part of something relates to the whole. So here also, I'm just saying on what day was the least amount of chocolate milk sold. So in this case, I can represent it good well compared to my bar chart. See the least the graph which is having lesser thing, it shows that that is the least sold day. So in this case, you can go with pie chart, and the other one is line graph. So it is it shows the continuing data, so how one thing is affected by another. See, when you see this line graph, you can say Monday it starts, Tuesday the sales increases, again Wednesday it again increases, again on Thursday it drops, and again Friday increases. If you want to analyze this based on the time or something like that, then you have to go with line graph. It is continuing data. So on what day did they have a drop in chocolate milk sales? Then it is very easy. When you draw a line graph from by looking at itself, you can see say that on Thursday there is a fall in the sales of chocolate milk. So you have to use a correct graphical representation for the variables. And a histogram. So when I say histogram, it is a special kind of bar chart. So whatever we have seen, but one thing you have to know is allows us to visualize distribution of values of an ordinal or continuous variable. So there will not be any gap. So in bar chart, when you see there is a gap. So Monday, Tuesday, Wednesday, there is a gap between the bars. But in histogram, there will not be gap in the bars. It is be continuous. So many times the value will look like normal distribution. We always map with your bell shaped curve. See that violet color line, so where it will represent a bell shaped curve. So it is very good for comparing multiple ranges of values. I have different ranges of values, and if I want to compare it, then I can go with histogram. Box plot. So it has a 5 point summary of data: mean, quartile, range, and so what is it actually? So yeah, box plot is also called as box plot. I will call sometime as box plot, and whisker plot. I will call it as a whisker plot also. So it is used to picture the distribution of values. Look at the picture. So I'm just going to measure the temperature range of the city. So you,
Ma'am,
when you see, yeah,
you are not displaying the charts. Yeah,
now
now
it
I
is,
can see.
so when
Yeah,
I
you
make
missed
full
it.
screen, it gets stuck sometime. Okay,
Oh, yeah. Actually,
that is the
you.
problem. Now it is visible. If I make full screen, sir, it is just stopping where I have to shift, go back, and okay, it's all right. I'll do it. Okay,
No problem. I'm sorry
uh,
about that.
it's all right. So when you use a box or whisker plot, you divide the data value into 4 parts quartile. See, you have 3 lines, blue color and yellow color is there. In that blue color itself, the median splits the data value into 2 halves. finding the median for each half. So for each half split, you can find the median, and the data values you will have four part. That is why it is said as four part quartile. Okay, so if you want to represent like that, then you can go with the box plot, scatter plot. This will be mostly you used, because if I want to fit a line, first what I will do, whatever data points I have, I will plot a scatter plot, and I will try to fit a line in such a way that all the points are close to that line. So it is an scatter plot is an excellent tool for comparing pairs of values, predicted value and actual, how it is the line, whatever available in the line is the predicted value, and the data points available shown in the graph is the actual value. So the difference, so it is the best plot to show the comparison of two values, and you can identify the outliers very easily. So whenever you have numerical distance, so here when I say the difference between actual and predicted value, we always find the difference between these two values, a distance. So how far it is away from the predicted actual value from the predicted value. So the numerical distance, if it is very far, then I'll consider as an outlier. So I'll remove this outlier. So an outlier is an observation that is numerically distant from the rest of the data. Suppose I'll will consider an example. Bill Gates makes 500 million a year, but I just want to compare the salary of 10 teachers, and out of that one is getting 40,000, 45,000, 55,000, something like, and I'm asking you to find out the average, and Bill Gates is also sitting in the same cloud. So what will happen? So nine members are teachers who are getting 45,000, 30,000, 50,000, something like that, and Bill Gates is 500 million. So if at all I want to find out the mean salary of everyone in the room, it will be absurd to find the mean salary because he is an outlier. So whoever the data point which is far away from the rest of the data should be considered as an outlier, and it will, so there are few plots which will easily help you to identify the outlier. One is a scatter plot. You see, the scatter plot is useful for eyeballing the presence of outlier. So if you draw the line from the plot the points from that graph itself, you can identify, because one point is which is in the line 5, it is far away from the rest of the data point. So you can easily identify the outlier using your scatter plot. And here also in box plot also you can find out whether it is far away from the center point, above or below. Both the cases you will consider it as an outlier and you will remove it. See the graph. So only in 2 points it is picking up. So they are considered to be outliers, easily identified, and you can remove. And the next one is most important thing is hypothesis. So now we'll see what is an hypothesis, because before defining getting into modeling, you have to define the hypothesis well. So only when you define the hypothesis well, you will be able to find out whether it is predicting correctly or your model is working fine or. So, what is a hypothesis? Hypothesis testing in machine learning, how it is used, and what are the steps involved in hypothesis testing and errors? What is testing of hypothesis? So, whenever I say hypothesis testing, it is nothing but an answer. It is an answer to my statistical framework. So, I have to ask few questions, and based on that answer, I will take some decision. So, your hypothesis tests are used to make comparisons. So, an hypothesis is an explanation for something. It is a provisional idea. So, and guess that requires some evaluation. I'm guessing. So, if this is so now it is seem to be cloudy, so it is going to rain definitely. I'm guessing it. So, based on some data, I'm guessing it that, but I need to evaluate. So I have to collect some data. Whenever it is cloudy, I will collect all the data and I will come to a conclusion. I have to define an hypothesis. Oh, whenever it is cloudy, it is raining. No, it is not always. So I have to contradict also. So that is how you define the hypothesis. A good hypothesis is testable. It can either be true or false. You will come to a conclusion whether it will say yes or it is no. In science, a hypothesis is falsifiable, meaning that there exists a test whose outcome could mean that hypothesis is not true. So, falsifiable. So, outcome. So, you are conducting a test and the hypothesis is not true. So, the hypothesis must also be framed before the outcome of the test is known. So, you have to, before testing it, you have to frame the hypothesis. So, these are all. Few examples of compare. Is the new machine faster than the old machine? I have to compare. I have to write an hypothesis and I have to predict it whether it is true or not. So is the level of compliance higher now there otherwise whether it is higher in final year. So all these things can be done with the help of hypothesis. So hypothesis is that best fits the evidence and it will be used to make predictions. It is called theory. So whenever you are giving explanation that fits the evidence and can be confirmed or disproved, then you call that as an hypothesis. So next, hypothesis testing in machine learning. So, what is hypothesis testing in machine learning? So, it is used to draw the inference. Our aim is to get some knowledge from the data. So, if you want to perform that, so I have to perform hypothesis testing to draw the inference or some conclusion about the overall population. I'll take a sample and I will infer the I will generalize and I will apply that inference to the overall population. So the same inference are drawn from different machine learning models. So you can apply. There are so many tests, not only t tests. So many tests are there. So you will apply test to draw the inference. For drawing some inference, we have to make two assumptions. So they are null hypothesis and alternate hypothesis. For drawing any inference, what you have to do? You have to define two hypotheses. One is null hypothesis, another one is alternate hypothesis. What is null hypothesis? So there is no anomaly pattern or believing according to assumption made. So I'm just going to discard. So there is no such thing going to happen. If I say like that, then it is said to be a null hypothesis. Contradictionally, so it shows the real observation. Whatever is going to happen, yeah, it is cloudy, it is going to rain. So it can be used as an alternate hypothesis. Likewise, you have to define two hypotheses. One is null hypothesis and another one is an alternate hypothesis. Anyway, any one of these will be true. Next, p value. So when I say null hypothesis, you have to understand one thing that is it is commonly accepted or considered to be the status. So it is denoted by H naught. We always give the notation H naught for null hypothesis. So you will say when we
Hello, ma'am.
yeah.
Yeah, again, the screen we are not seeing.
Yeah,
Yeah,
now it is okay. Okay.
yeah. I'm
Uh,
sorry. I
It's
then and
all
there
right.
I interrupted you.
I think I don't know whether it is an internet problem or it is not. Mm.
Okay.
Okay. So this is regarding your null hypothesis. And before that, you have to know one thing is critical region. So critical region is defined as a region of value which will lead to rejection of null hypothesis. So by drawing the graph, you can identify whether it is in critical region. If that is available in the critical region, then you can reject it. And this p value you will use it as level of significant, how far this is good. So you, in order to identify test that, you will go with this p value. So critical region is defined as the region of value in distribution which will lead to rejection. So rejection of null hypothesis we will see now. For there are different tests, one tail test and two tail test. So one tail test where your critical area of distribution is either you will say it is greater or less than a certain value. If you are able to say like that, then you call it as a one tail test. So how to write your an alternate hypothesis for this one tail test? So your null hypothesis is always represented as H naught, and your alternate hypothesis is always represented using H1. So in this case, you will give an alternate hypothesis like this. Either you can take mu1 greater than mu2. So whatever value you are predicting should be greater than this. Otherwise, you can come to a conclusion that it is less than the mu2. Either it is greater than a certain value or less than that certain value. And two-tailed test is a statistical hypothesis in which you have both the sides. So it's on either side of the side. You cannot say that it is lesser or greater than. Only thing I'll say is it is not equal to the specific value. So if you define an alternative hypothesis like this, then it is said to be two-tailed test because the critical area of distribution is on both the end, left side and as well as the right side. So here is the turn. Here H naught is more probable. That means mu value is greater than the given value. So when you see the second diagram, it is less than the value. So in this case, it is available in both the sides. Then you will go with the two-tailed test. So based on that your sample, so whether it is falling on the right side or left side, you will accordingly you will define the alternate hypothesis. So what are the steps involved in uh, hypothesis testing? So before that, when I was telling about p value level of significance, so you should have a p value by 5 percentage. That means 0.05. So if it is less than 0.05, then your model is very good and you are able to identify make the prediction correctly. Okay. So steps involved in hypothesis testing. First, you have to collect the sample and then calculate the test statistics. You have to decide whether you are going to accept or reject the null hypothesis. So, for that, how to you have to calculate the test or t statistics. So let us take one example to perform this. What I'm going to do is I'm just going to consider a shipping container where each container box is 100 kg. But what I'm going to do is I want to know whether it is exactly 1000 kg or less than that. So now I'm going to proceed the data collection. What I'm going to collect, I will collect the weight of all the containers which is available and I will find out the average weight and I will also find out the standard deviation. So I will calculate the test now. So some may be 90, some may be 80, some may be 100. But I want to calculate it whether it is less than 100 or not. So now what I will do, I will apply some statistics, I will find out the value. So if the level of p value or t value, so it is exactly what you expected, then you say your hypothesis is okay. Otherwise, you will reject the hypothesis. Okay. So there are two types of error in hypothesis. One is type 1 error and another one is type 2 error. So whenever I say testing, you are doing the testing on sample of data rather than entire population because we cannot collect the entire population. Sometimes will not have. So you will have a sample of data and you will draw the inference only out of that sample. So there may be a chance of errors also. Type 1 error. So when your whatever you have defined is correct, you are rejecting it. In that case, you will call it as type 1 error. In case if the whatever you have defined is not true and if you are accepting it, it comes under the second category, type 2 error. So now let us take one problem, how to write your hypothesis. So there is a situation, a man is on trial for murder, so he has murdered someone. So both the prosecution and the defense present the evidence. Both are presenting. So the prosecution as well as the defendant. So they are presenting evidence. So one is saying he is not guilty, he has not done anything. The other one is saying he is guilty. So not guilty means the prosecution has failed to establish guilt beyond a reasonable doubt. So if at all he has done the murder and if I say he has not done, then it is going to be the type 2 error. So if he has not done, and if you are rejecting, then it is going to based on this only you are categorizing as categorizing it as type 1 and type 2. So when it is true he has done the murder, but I am rejecting, I'm saying I have given a judgment that he has not done the murder, then it comes under your type 1 error. So, and if he has done the murder and I am saying it is not, then see in both the cases, so you say it comes under either type 1 and type. So, both things should not happen. So, you have to define an hypothesis in such a way, okay, by understanding the data. So here if I say, if I want to write an hypothesis, I will write like this: h1 h naught, I am saying defendant is innocent, that means he has not done the murder. But h1 alternative hypothesis is he has done the murder. So both are providing evidence for h naught and h1, and based on that I have to take a prediction. So when he is not guilty, and if I say decision that he has done the murder, then it will be rejecting h naught in favor of h1. He has done, but I am saying that he has not done, then it is type 1 error. The next one is he has see type 2 error, false negative. He is guilty but he has been relieved. So accepting in your h naught, but it is not true. So in this case it is coming under type 2 error. So, setting up the first, you have to determine the testing hypothesis. That is more important. Find out the null hypothesis. You have to take a random sample from the population and then apply it. Calculate the test statistic. So, if the test statistic is consistent, given below the given range, between the given range, then you accept or decide to accept the null hypothesis or reject the hypothesis. So this is the steps followed in hypothesis, and there are so many tests are available, like z test, t test, chi-square test, and f test. So different types of probability model for different types of populations. So based on this hypothesis tests are selected. Okay. So so next comes your machine learning. Is it visible, ma'am?
Yes, ma'am.
Yeah, yeah. 1 second, I'll just switch over.
Ma'am,
1 minute,
excuse me,
ma'am.
ma'am.
Yeah.
Ma'am, actually your side is not visible.
No, no, I have not shared, sir. I said 1 minute I'll share.
Okay, ma'am. Okay, ma'am.
Yeah, I have not shared. Hello. Yeah, now you're. Is it visible?
Machine learning algorithms, ma'am.
Yeah, yeah. Yes, madam. Is my screen visible now? I'm just scrolling it. You're able to see?
No, ma'am. It is not getting scrolled.
The problem is when I make full
Uh,
screen, it is a
now,
problem.
now
Okay,
it is.
now it.
Now,
Yeah,
now it is.
Okay. So now we'll get into machine learning algorithms. So learning ability is one of the most fundamental ability for realizing intelligence. So you have to learn more to understand the intelligence. So you are developing a system with learning ability which can become more and more efficient and which is capable of solving the problems. So now I'll just give you a few things about AI and machine learning, and then we'll move to machine learning algorithm. Why we are going for machine learning? So AI and machine learning is a research field for studying theories, methodologies, and algorithms. So you have to make intelligent system. That is our ultimate aim. So around 1960, so the first wave of AI came. What it does is inference with a given knowledge. Whatever knowledge you have, from that you will make some decision. So for example, given some knowledge, I'll make a decision. For example, I. So if I give I, then it will say you're a man or you are a human being. So whatever knowledge given based on that, it will make decision. And around 1990, the second way of AI learning with given data came. If I give a data I, it can learn like a man. So whatever you with the given data, it will start learning itself. In 2020, the third way of AI came, where an environment for learning is given. So, what is that environment? Your cyberspace. So, given the internet, I will collect all the data and I will learn in a different way from. So, it is not working similar to human being. It is thinking different way from human being. So, that is around 2020 currently, and beyond that, you have. Fourth way of AI, it will be coming around 2050. So where it will think beyond human. Nothing is needed from man. I will take everything. I can do myself. So that is going to be the fourth way of AI. So, what are the fundamental difference between artificial intelligence, machine learning, and deep learning? So, when I say artificial intelligence, so it is said by your Professor Andrew Muir, the science and engineering of making computers. So, it is making computers behave in way similar to your human intelligence. So, what are the components it required? It needs a computer vision, it needs a language processing, it needs creativity and summarization. So, these are all available with your AI. When I say machine learning, so which focuses on study of computer algorithm, so what you are going to do is you are allowing the computer program to automatically study it and improve the prediction based on the experience. So here we will use classification, neural network, and clustering. So in case of machine learning, so in deep learning, it is nothing but a subset of machine learning where you will go with the layered networks combined with more powerful and very big data set. So these are the few main difference between AI, machine learning, and deep learning. Now, introduction to your machine learning. Why, how, and what? Why machine learning? How we are going to use machine learning, and what is the purpose of using the machine learning? Suppose if I ask you to write a program of adding two numbers, okay? So I'm going to simply give number 1 plus 1, 2 plus 2, 3 plus 2. But what I'm going to do is if at all I'm training it as 1 plus 1, 2, 2 plus 2, 4, 3 plus 3, 6. Yes, I'm writing a code, and if I give the input, any input, it will add. And suppose if I ask you to do multiplication with the same program, will it work? Absolutely no, it will not work, because you have written a program for addition and you are trying to get an answer for multiplication, which is not possible. But if I give you another example, I'm writing I just give you an logic 1 plus 1 equal to 11, 2 plus 2 equal to 22, 3 plus 3. I'm just asking you to find out. Immediately you will reply it is 33. And the same thing, if I give 1 plus 1 equal to 10, 2 plus 2 equal to 20, 3 plus 3 equal to what? If I ask, you will say 30. But Will that many programs will write this? Will it, if I give 1 plus 1 is 3, 2 plus 2 is 5, 3 plus 3, will it be able to predict? No, you need to write a separate program for every logic. So, if I had only one program, will it be able to solve all these three logic? No, it is not possible. But this is where the point where your machine learning comes into picture. You need not write different programs for different logic. What it does is, with hard coded rules, and you are letting the system understand the logic and produce the desired output. So that is why we go for machine learning. So when we write a code 1 plus 1 equal to 11, it will be able to think only 2 plus 2. If I give, it will be able to think to produce only 22. If I give some more logic, 1 plus 1 10, and 2 plus 2 20, and 3 plus 3, I am giving some input early. 1 plus 1 10, and 2 plus 2 20 is given. Even though I give those two, if I give 3 plus 3, it will not be able to generate 30 because I have written for only particular logic. But this machine learning will understand the system, understand the logic, and it will produce the desired result. So that is why we need a machine. We are going to machine learning. So here, when you write a traditional programming, you will give the data as input, and you will write the logic, and you will give it in the computer. So the program will process the data and you produce the output. But in machine learning, you are giving the data and the output you want, but it has to select the program. So this is what machine learning is doing. So you will give the data and the expected output, and it will produce the program for it. So what is machine learning? Machine learning is all about learning from data, building the logic, predicting the output for a given input. If you given input, it has to predict the output correctly. So that is what they called as machine learning. So there are many definitions for machine learning according to Arthur Samuel. So he has defined machine learning in 1959. It is a field of study that gives computer the ability to learn without being explicitly programmed. So it is not explicitly programmed, but it understands the logic by itself and it produces the output. So that is the definition given by Arthur Samuel. And Tom Mischel, so he says a computer program is set to learn from experience. If I it has an experience is nothing but past data with respect to some class of task. So if I am giving the task and experience, if I measure the performance, if its performance at the task in t is measured by P, it improves with the experience. As you increase, as the experience increases, then what happens? Your performance is also increasing. So we can break the entire thing into two parts: learn from the past experience and improve the performance of intelligent program, because you are increasing the performance based on the experience. So these are the two parts of it. Now, machine learning, what does it do? How does machine learning work? And why do we need machine learning? What does it do? It enables a computer or a machine to make data driven decision. I'm going to train the system with the given input data, and I'm getting some output out of it. So to make the data driven decision, rather than being, I'm not going to explicitly program. So I'm going to train the system. These programs or algorithms are designed in such a way that they learn from the data and they improvise the system over time when they are exposed to. Every time when you give a new input, it improvises the system and it gives better performance. So that is why it says it takes a task T, executes it, measures the performance. Now what happens? Now a machine, every time it does, it has a large number of data. So, in order to process the data, it needs an experience. As the experience increases over time, the performance will also be improved. So, after going through all the data, your model's accuracy will be increased and it will predict well. So, this is what machine learning is doing. And how does machine learning work? So machine learning algorithm is trained using training data set to create a model. Whenever you give a new input to that model, it makes a prediction based on the model. So the prediction is evaluated for accuracy. I am going to check whether it is correctly predicted or not. If the accuracy is acceptable, then you say it is a good machine learning model and you can deploy it. If the accuracy is not acceptable, then you have to train the system again and again until you get a better accuracy. Okay, so that is what our machine that is how your machine learning works. Why do we need machine learning? So we have, for example, I have set of images. I have many images like cat, dog, so many things are there. What I want to do is I want to group it. I want to put cats and all together, dogs and all together, and so to do that, we need to find out different features. So that is what where feature comes. First thing is I have to find out how to differentiate these two pets. So whether it is a cat or a dog. Then now what I should do? I have to ask so many questions. How many eyes does each animal have? Is the color of what is the color of the eye? What is the height of the animal? Weight of the animal? What does each animal generally eat? With all these questions, I'll form a vector. For every question, I'll form a vector. So it is nothing but a feature. So eye color, so weight, eat, so etc. Now, after forming the vector, now I'm going to apply a set of rule. What is that rule? If the height is 1 feet and weight is less than 15, I can just define it as I can identify it as a cat. If so, likewise, you have to make a set of rules, and based on that rules, if it falls under any of the category, I'll put an if else, and if any one of the category satisfies, then I will categorize into either a cat or a dog. Let us assume that the result of this experiment was not fruitful. So, a few of the cats are even identified as a dog because even small dogs are available. So, it is not performing properly. So, which gives an excellent opportunity to use the machine learning here. What machine learning does is the different day kind of algorithm. It takes the data, it applies the different types of algorithm, and first thing you have to do is you have to identify the most important feature. I may have hundreds of features, but among that, the most important feature which can be used to determine whether it is a cat or a dog need to be identified. So instead of applying many set of rules, what I will do, I'll go with two or three features. Based on that feature, I'll consider these features are more important to categorize it as a cat or a dog, and based on that I will identify it. This will give you accuracy than the previous method. So the previous method was not generalized enough to make prediction. It is generalized to make good prediction. So here machine learning models helps us in many tasks like object recognition, summarization, prediction, classification, recommender system, and others. So many fields you can use it. What is a machine learning model? So when I say machine learning model, you can imagine as a question and answering system. So it takes some inputs and it has to give some output. Think it as an algorithm which is going to represent data when you solve the problem. So it all these things we have. Next, consider this example. What given 20 years of clinical data, what I want to do, I have to predict will this patient will have a second attack. So 20 years of clinical data I have taken, and I am analyzing whether this patient will get a next heart attack in next 5 years. Is it possible? So what is the price for this stock? 6 months after, what will be the price? I'm writing some letter handwritten number, and I'm identifying whether it is written handwritten number or not, whether the email is spam or correct mail. If I tested together these customers, or articles origin. What is the best strategy when playing video game? Because video game there will be so many steps. So I what is the best strategy? So what will happen? You have to play. Whenever you fail, I will take it as an experience. I'll gather all the experience and the moves I have made, and I will train the data set again and again and again. And at some point, I will have a very strategy where I can win the game. So these are all few examples. Okay. And vocabulary. A input, there will be an output here in machine learning. When I have an independent variable, I will also have an output. So I will calculate and features, your target, whatever you want to target, that will be based on this feature. You will take some features and you
Ma'am,
will
your voice is breaking.
yeah, sir. Okay. So, types of machine learning algorithm. Machine learning algorithm can be classified into three types. One is supervised, unsupervised, and reinforcement. The first one is task driven. So you can apply either regression or classification. The second one is data driven. And the last one is it will learn to react to an environment. So first one, what is supervised machine learning? So in supervised machine learning, you will train the machine using the data. So labeled data. So I can easily categorize because the label is available. So I can have a correct answer. So the algorithm iteratively makes predictions on the training data and it is corrected. It is like somebody is monitoring us, and if we do some mistake, it is correcting. Already labels are there. It is very easy to classify it. So when it will stop learning? Learning stops when the algorithm achieves an acceptable level of performance. So whenever I say supervised learning algorithm, it learns from the labeled training data. So it will help you to predict outcome for unforeseen data also. But anyway, you have the label. So it is like a teacher who is guiding you to determine the value. Now, when this is the supervised pipeline, first you will have the training data. You will find out the feature, most important feature, and then you will identify the machine algorithm, and then you will make the model. So in the training period, you will give the label. Since it is supervised, your label is there, input is there, feature is extracted. You apply some machine learning algorithm, you just find out the in prediction also you have to compare the predicted value with the actual value. So that will give you the actual value, and now you are doing prediction, input, feature extraction, and classifier model, whether you are able to produce the same label. If you are able to produce the same label, well and good, your model works fine. So otherwise you it is insufficiency of training, you have to do it again. So now, supervised learning is where you have input variable x and an output variable y. So when I say output variable y is equal to f of x. Now what you want to do? I have to find a function, mapping function in such a way that whenever I give a new input data, you should predict the output variable y correctly. Y is equal to f of x. So the supervised machine learning is best understood as an approximating the target function. So the target function is f of x that maps the input variable x to the output variable y. So this characterization describes the range of classification and prediction problem, and the machine learning algorithm can be used to address them. So wherever you have this classification and prediction problem, you can go with this. An important consideration in learning the target function from the training is how will you generalize the model to the identify the new data. So generalization is more important when we collect when we design the model. So now this is an example. Training data includes both input and label. Now, what I am going to do is I am going to write an algorithm, train the system. I'm going to give 5 and 6. If I add 5 and 6, obviously it should produce the output 11. So, according to my machine learning model, I will give the output data as well as output, and I will find out the algorithm. So 5 and 6 is given and 11 is also given, and the logic is addition. The same way, this is the training with training data. Now, the same thing in prediction side, what I'm giving, I'm just giving the data alone. What is that? 2 and 4. Now, it has to apply the logic and give the value. What is that? Well, output is 6. This is what done in the training and the predicting. So in the previous diagram, this is what done. Training, you will give the label, input, whatever done, apply the algorithm, and you will produce the output. So in the prediction, you give the input and you apply the logic you have designed and get the output. So we first train the model with the many data inputs and targets. Then with the new data, whatever you want to use, you apply the logic and you try to get the output. So this process is called supervised learning, so which is fast and accurate. So the challenges in supervised machine learning is irrelevant features. Sometimes you may give irrelevant features while doing training the data, which may give reduce the accuracy of the result. And data preparation and pre-processing is a challenging process, because whenever you give an incomplete data, then in the training period, then it will also give an inaccuracy may increase. So these are all the advantage of supervised learning. So it will allow you to collect the data, produce a data output for the previous experience. You have the label, so you can do it. So it will help you to optimize the performance criteria using the experience. It will help you to solve various types of disadvantage. You, if you consider decision boundary might be overtrained. If your training set is not having enough example, then it is going to be a problem. You need to select lot of good examples to train it. So classifying the data itself is a big challenge here. So training for supervised needs a lot of computation time. So these are all the disadvantage of supervised learning. So before doing anything, you need to decide what kind of data to be used as a training set when you want to go with supervised learning. You need to design the structure of the learned function and learning algorithm. And then after that, you gather the corresponding output from the expert or from measurement. Then you apply the supervised learning. So these are all about your supervised learning. So there are two types of supervised learning. One is classification, and another one is regression. So the first one, regression. So this is a type where you predict the continuous response. So here, so the continuous value, you will predict the continuous value. A regression problem is when the output variable is a real value such as dollars, or some of the example is this one. What is the price of house in the specific city? What is the value of the stock after 5 years? Oh, how many total runs can be on board in cricket game? Something like this. And now classification. So this is a type where you predict the categorical response. So there I said it is continuous. Here it is a categorical response where you will separate into a specific classes. So you will identify whether the mail is a spam or not. You categorize it, say yes or no. Then you consider it as a binary classification. If you have multiple classification, then it will come under multiple classification. See, in the case of spam or not, it will rain today or not, it is a cat or not. In the all these cases, there is only two answer, either yes or no. These can be categorized as binary classification. But if I say this mail is spam or important or promotion, I have three classification pretty way. Either it can be a spam or important or promotion. Cat, dog, or tiger. So there are multiple class labels. So it will come under multiple classification. So when I say classification, it separates the data. So your graph will be like this. When I classify, you will similar kind of data will be grouped and it will be classified like. When I say regression, it fits the data. You will draw a line in such a way that all the data points are close to that line. So this is regarding classification and regression. Next one is unsupervised learning. So when I say unsupervised learning technique in which the user does not need any supervisor, there is no label at all. You have to discover the pattern, get the information, and then you have to produce the output. So why we are going for unsupervised learning? The model learns through observation and it will itself find out the structure on the data. So once a model is given a data set, I have a model, I'll give a data set. What it has to do, it has to automatically find out the pattern and it has to automatically find out the relationship in the data set by creating a cluster. So here comes, and when I say unsupervised, then you will go with clustering. What it cannot do is no label can be added to the cluster. Based on the similarity, it can be group. So, like it cannot say this is a group of apple or a mango. So, if I give all green color, it can be clubbed together. That is also possible. So, it will separate all the apple from mango. That's all red color, green color. That is what it can do. Based on some features, similarity, you can separate it. Suppose if you are presenting apple, banana, mango to a model, based on some patterns and relation, it will create a cluster. But we cannot say that it will be all the mangoes and bananas and apples will be separately grouped. Sometimes there will be mismatch also. So unsupervised machine learning will find all kind of unknown patterns. You have to train in such a way that it identifies correctly. So it will help you to find features which can be useful for categorizing. So in real time, all the input data need to be analyzed and labeled in the presence of learners. Then only you can cross verify it. So it is easy to get unlabeled data from computer than labeled data because unlabeled data are so many. So labeled data you need manual intervention. So the training will not include targets here because we do not tell the system where to go. I don't have any thing. So it has to learn him itself and understand the pattern and then it has to apply. So training data is not structured. It may contain noisy data, it may contain unknown data, etc. So suppose if the unstructured data is given, what it has to do? It has to first understand the structure pattern of the data and then it has to train itself. Then it has to draw the inference. So this is regarding unsuper. When I say clustering, we group similar things together. See, blue color, green color, and see even in there also here and there some red, green are available. So bit similar to multi-class classification. It is similar to multi-class classification, but you don't have a label. The system has to understand the data itself and then cluster the data. So here are some examples given news article. You can cluster based on the type of the news. You can cluster it. Okay. So application of unsupervised machine learning is clustering. You can automatically split the data set based on their similarity. So in that case, if you don't have any label, then you can go with this anomaly detection, association mining. So all these things you can go with the unsupervised learning. So disadvantages, you cannot get a precise information about the data sorting outputs because there is no label available. It's not known. Less accuracy of the result compared to that supervised. And spectral class do not always correspond to the informational classes, so it will not exactly be fitting. So the user has to spend time, so it has to get some experts information from experts, or they have to spend some time in interpreting and label the class. Then you have to compare. So these are all few disadvantages of unsupervised. So this is how when you say supervised learning, since you have label, you can easily classify it. But unsupervised learning, I'm just grouping is based on the similarity. So based on some similarity, everything it looks alike because there is no label. So I have to based on the similarity, I have to group it, cluster it. And supervised learning, when I have discrete data, then classification and categorization can be applied. When I have discrete and clustering, unsupervised learning, in case of that, clustering can be a, when When I have continuous data in supervised learning, I have to go with regression. So in case of unsupervised learning, dimensionality. These are all the learning problems that occurs with discrete and continuous. And the last one is reinforcement learning. So it describes a class of problem where you have an agent who will operate in the environment, and it has to learn to operate using feedback. So here there will be a feedback, based on that it will learn. So the use of an environment means there is no fixed training data set. That you have to remember. When you have a data set, I will not go with the environment. So there is no fixed training data set. Rather, I will just set the goal. An agent is required to achieve that goal. So actions they may perform, whatever feedback they are getting, they will get it. They will improvise the system, find out which is the best outcome, and then they will do it. It is like hit and trial concept. So when the agent is rewarded or penalized with a point, if he identifies it correct answer or wrong answer, it may be a positive reward point or negative in reward point. But what he has to do is he has to get the feedback and train the system by itself. So trained, it gets ready to predict the new data present to it. So many complex domain, you will go with reinforcement learning, because you only feasible way to train the program at a high level is reinforcement method. So because in for example, in game playing, it is very hard for a human to provide accurate and consistent evaluation. It's not possible. As you play, when you lose or win the game, what you will do, you will just evaluate put all the information as feedback to learn an evaluation function, and accordingly you will find out the best strategy to win the game. Why we need reinforcement learning? Let me consider a very basic example. I when consider a baby who is trying to step forward. It is just now it is trying to walk. The baby first time it will fall, roll. It will be since the floor is slippery, and the environment is not much predictable for the baby because it is not understanding. So what it is doing is it will try to learn from the experience. First time it will get up, it will fall down, then it will try to balance itself, and it will try to walk. So when we want a system to accomplish a task by understanding the task by itself, the system has to apply the trial and error rule. So it has to lose and it has to win. By getting the feedback, it has to correct itself, and then it has to build the model. Where it is really difficult to use, either you cannot go with a supervised or an unsupervised learning method, because it is a trial and error method. So here we need new method. So that is why reinforcement learning came. So in RL, the few steps that you should define before is you have to be very clear with the goal as well as the environment in which you are going to apply it. And you have to define a set of possible actions an agent can take. And the third one is you have to define a system called rewards. If a goal is achieved, it may be a positive, otherwise it is a negative. Like when a baby try to get up and walk, when it falls down it is a negative, and when it is try to step forward, then it is a positive reward. So, here an agent will take the action from the present state to enter into a new state. Based on that action, you have to decide whether it is a positive or a negative. So, maximum reward, based on that, you will try to complete the goal. So, the reward system should be set by us, feedback should be collected, and the reward feedback does not tell the agent directly what he has to do. Rather, it will indicate how valuable some sequence of states and actions are. So, it is not going to say that this is going to be the best one. This is no. It is going to give the whatever action it has done. It is going to give it as feedback. So, what it has to do is he has to indicate it. It indicates the valuable. So some states and actions, these are all valuable. So you have to use it. So this is done. So an environment is given, an agent is given. Based on the observations, the feedback is given to the, and then action is performed. So that is what given. When the baby tries to attempt to take a step forward, it may fall, roll, and the environment is not very, with the help of trial and fail method, it has to go with it. So what ML do is three main tasks. The goal is, in case of supervised learning, you have to learn the function. Unsupervised, find the groups and relationship between the group element. Reinforcement, optimal control. So subtask is supervised learning, you will go with classification and regression. Unsupervised, clustering, density estimation, dimensionality reduction. And reinforcement learning, value estimation and process. So these are all few algorithms and applications of H1. So I think we will stop with this. Madam?
Ma'am. Okay, ma'am. Ma'am,
Yeah, I think it's 12. We'll stop with this and we will start by 2, madam.
okay, ma'am. There is some queries in chat box, ma'am. I think I couldn't able to see that query.
Yeah, pre-processing
Ajita
too, then why?
Padmanabhan have posted one query in the chat box, ma'am.
Yeah, slide is not moving and all those things they have given, madam.
At starting stage, ma'am.
Yeah, now I didn't get any query. Anyway, I'll answer.
Ajita Padmanabhan, ma'am. Okay, ma'am. Participants, if you have any queries, can you please ask? Ma'am, if no queries means we will end the session and we will start at 2 o'clock, ma'am.
Okay, ma'am. Thank you.
Okay, ma'am. Jayaraman sir, if you have any queries, you may ask. Okay, ma'am. We will end the session now and we will start at 2 o'clock, ma'am. Participants, now the session is closed and again the session will be started at 2 o'clock. I request the participants to join before 10 minutes of the session.